Okay, hey everyone. Scorpion, congrats on the first. Spetri, get fucked. But no, I hope we both are doing well. Uh, you know what, Scorpion? I've seen you use that gummy bear email before. Do you remember like how you unlocked it? Because I seem like I don't have it. That's fair enough, Spetri. Yeah, you are nearly doubling second place. Okay, but oh wait, I'm not playing music. There we go. I want to clean up this PDF. It's allegedly supposed to be just the physics study problems. When someone asks a question, I just make a new page and do it there, but then I don't clean up the pages that I made. We can get rid of this. Can definitely get rid of that. Got a tip for today? All right. Fair enough. Thanks for saying hi. I'll see you. Oh, this one we'll keep around. We didn't actually figure out number 9. Number 9 gets a little crazy. I don't know if I want to, but we'll keep it there just in case. Wow, how much garbage do I have here? That can also go. That was a fun problem. Okay, so we just did number 14 in the physics. I think I skipped over 13, but 13 is going to stay skipped, I think. So I guess we'll go to 15 because I see we have a header. The following 5 problems have a common theme, so it might be worth it to go through all these. We'll do a couple of different screenshots for this one upon further consideration. This thing just won't. It keeps snapping to the wrong place. Like, don't snap there. It's not okay. You know what? Left arrow key. There we go. It's about right. Okay. Two equal masses m and a spring with spring okay. I was gonna say a spring with another spring. I was like, what? But no, spring constant. Coefficient. Oh, there's friction here too. Bruh. How far does the spring stretch before the masses come to rest? Huh. So the only thing that's going to cause the system to move is this mass that's dangling. Um, Now I assume we're supposed to use energy here, but I kind of like why like could we just look at the forces on this other block and find what value well and like assume that the force due to gravity is equal to the force from the spring plus friction. Well, friction if it's going to be at rest, friction doesn't matter, I guess. But I guess it's going to stretch a length x. This the spring will, and the mass has to have the same, or the mass down there has to have the same displacement. So I guess in the starting state, there is gravitational potential energy from this mass and only that, right? How do we... I'm getting confused on how this is being like rotated. Like if I'm saying zeros right here, what's zero potential energy for this mass? Like I guess it would be mgx. We would consider it to have like a height x, and it'll eventually go down to zero wherever it comes to rest. And so then there's going to be work done by friction, which I believe well, we'll just go back to the integral that we were doing in the previous problem. Integral from 0 to x of the coefficient of kinetic friction. They don't give us static friction. Interesting. I guess for the sake of work, though, we only worry about kinetic friction. Um, 1/4 times the normal force mg between the mass and the table dx plus the potential energy of the spring once it's been stretched by length x. And in theory, we solve this for x, I guess? See what answer we get. Oops, no squared. Okay, so then we're only interested in this bit. Who even cares about x equals 0? Not me. think I can normally do this in my head, but today I just can't. Um, 3/2 mg over k. The units check out. Do I have any intuition for whether this makes sense or not? It makes sense that x should be bigger the more mg is. Or, you know, the greater the mass is. Because the gravitational potential energy from that mass matters more than the work done by friction for that mass because the coefficient is a quarter. As the spring constant k gets bigger, x is smaller, and I think that makes sense because a bigger k is a stiffer spring. Okay, I guess I can go with that for A. For B, minimum value of the coefficient of static friction for which the system remains at rest once it has stopped. Well, this is where the result we just got comes in handy. This is this problem. The last one are kind of like scaffolded pretty well, where you have to use the thing you just derived to answer the next question. Hey Rapture, how's it going? Um, okay, so I'm gonna make a free body diagram for that mass right there. I'm doing good too. Thanks for asking. I'm just working on some mechanics studying while we wait to see if someone pops in with a question. Okay, so in this scenario here, well, no. The mass has gone as much to the right as it'll ever go. And we're asking when it's going to start to go to the left. So if it's going to go to the left, I'm going to say that our static friction is going to the right. So we want kx to equal mg plus f mu s. X we just solved. Static friction is mu s times x. No, 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 no. Mu s times the normal force. Mu x is the work, I guess, done by, or well, mu. I feel like mu x as something to. I remember seeing that formula somewhere in a physics class that I took. I don't remember what it would be though. It's almost the work that done by friction, but not really. So you need the normal force in there too. So I think the whites are just on. The lights are just on white right now, and that cannot stand. There we go. This song kind of sucks. And it's really quiet. Okay. Um. So I'll get a 1/2 mg is equal to mu s mg. Really? So we get something that's unitless, which is a good sign. I'm surprised it doesn't have some kind of dependence on mg or k. Um, and I guess it works out that way only because these two masses are equal. I have a feeling it would depend on the masses if they weren't equal. In part C, so I guess they're asking once the initial motion is you stretching the spring out to the right, but then if you suddenly cut the string, how far does it compress all the way to the left? Is how I'm interpreting that. And why isn't it equal to, oh, it wouldn't be equal to the, we still have friction. And the dynamic string are just going to be different when that mass isn't attached, right? Well, no, I feel like if there wasn't for friction, it would be equal to the original extension. Maybe only the friction matters. Um, so in part C, we only have potential energy due to the spring, for all intents and purposes. 1/2 k x squared. And I believe it's the same x. Yeah, it should be the same x as we just calculated in part A. And we want that to be equal to whatever the new spring potential is, which I guess I'm going to call... I okay, we're going to do x1 and x2, I guess. Plus work done by friction. I think that's okay. And so the x1, I'm calling the x1 from part A. We're just learn this for x2. What are we... I guess we're going to do this. Minus 3/4 mg equals 0. Is that what we're doing? Yeah. Um, and does this... No, there's no way this factors cleanly. I think we got a quadratic formula of this. Okay. Song sounds familiar. Yeah, I've probably heard it, but I don't recognize the name. Anywho, I hope we get a. That's why we're gonna get a perfect square underneath the square root. What are we getting? Getting a positive number on the right side. That doesn't mean I have to like it, though. Well, now what? This is a stupid number. Um, I don't like stupid numbers. Oh, sorry, can you hear that tapping? Do we want to approximate this? Did the units check out? Force squared. Ooh. No, they don't. Because this is force squared per meter. Where did I go wrong? At the moment we give the string, or at the moment we cut the string, for all intents and purposes, we only have spring potential energy. Do we not? I think so. And then by the time it gets maximally compressed to the left, we're going to have spring potential energy from the new compression.
What am I measuring x2 relative to?
I guess relative to the 0 point I defined earlier. And then we would have lost some energy to friction. Hey, Takshio. I'm looking much better than before? Oh god. I don't know what I looked like but before, but thank you for the kind words. I'm doing well. I hope that you're doing well too. Oh, okay. Fair enough. Hmm. Feeling a little less happy now that I can. This is I'm having trouble with this part C here, but you have trouble writing piecewise functions for inverse trig functions. Um, a piecewise function for inverse trig functions. I'm not sure what that piecewise piece means. Piecewise piece. uh, because normally we don't write them in a piecewise way. So I'm wondering if I'm interpreting you right here, but the way that I think about the inverse trig functions is I start with the domain and range of the regular trig functions. So like sine of x. The domain of sine is all real numbers. So you never have like this fancy r or minus infinity less than x less than infinity, or even like open parentheses minus infinity comma positive infinity. These are all equivalent notations here. And the range of sine. Oh. So you're asking about inverse sine of some random number like 12. I think it just shouldn't be defined. Um, right as 4 pi minus 12 or something similar. Less than 4 pi. So maybe, yeah, I don't, I think that if you are in a situation like this, you've done something wrong, I want to say. Um, I'm trying to think of what that could be though. Let me just like plug into Wolfram Alpha and make sure I'm not doing something incredibly stupid here, or saying something stupid. I can live with moderately stupid, but not incredibly stupid. Oh, what the hell? It gets a number. Oh, it's an imaginary number though. I don't think you're talking about imaginary numbers. Um, yeah, I think this just can't. Hmm. Yeah, I feel like if you're in a situation where you have this, like something's usually gone wrong. Like you're saying you could try writing it as inverse sine of 4 pi minus 12, but the thing that goes inside an arcsin isn't an angle, so I'm not sure that the 4 pi is really doing much. Um, I always think of it as like sine of angle equals ratio, and so that means inverse sine of a ratio equals an angle. So trying to deal with angles inside the parentheses there just seems odd to me. Has something to do with bringing the given number in brackets within the defined inverse sine of theta. Oh, you're talking about like the composition stuff. That's funny. So I just saw that yesterday. Black Pen Red Pen was doing a live stream on YouTube for office hours, and he was talking about this for tangent of inverse tan. Well, you've been using the -1 notation, so I'll use that too. But yeah, you have to be similarly careful that tan of inverse tan isn't the same exact thing as inverse tan of tan. And it's not like you're asking for the same thing, but with sine. Central, 10th Street. Nice, nice. So I've only just learned this is really an important distinction, to be honest, from that stream. So let's think about it. So the thing that let's take something that's outside the range of minus pi over 2 to pi over 2, like pi. And let's think about what this should be. So the thing that you want to do when you see an inverse function with its regular function, you want to just cancel them out and get just pi. But that doesn't always work with these trig functions because of how funky their inverses are. What you can do is go work your way from the inside out. Like, we know what sine of pi is, which is 0. And inverse sine of 0, that should still be 0, right? Yeah. Whereas if we have the reverse direction, sine of inverse sine of pi, I believe this one just works. Oh, yeah. This is the direction where inverse sine of pi isn't defined, but you are allowed to cancel the functions and just say that it's pi. Jed with the 7th streak. I'm going to be honest. When I first saw Central's name, it starts with Jade, like, oh, hey, it must be Jed. But then I see you. And I have to like catch myself, and then there you come in, Jed. Yeah, so Takchio, I think the thing you're talking about is right, where if you have inverse sine of sine, I mean, to me, you just wouldn't simplify it, and you would just do the sine part first and then take the inverse sine of it. Central's the cool one? Oh my gosh. I mean, I might be the first person who's ever called Central cool. But I do see as +3 on you. Yeah, if you wanted to make this way work, what would you have to do? You might need to continuously subtract off pi's or something until you get in range. You know, if he's the hot one, you ever laid ads on him? Oh, fair. I don't know what he looks like either. He said he used to have a cam on a stream at some point, but it's before I knew him. Yeah, you know, I think it's one where I want to Google it. Inverse sine of sine. I am the hot one. I'm so hot my beard is even red. Hell yeah. This one is coming that's just not defined. if you go out of the range of inverse sine. Syntax. I got my Finnish uni entrance practicing back in the comment on it was too many mistakes to mark them all. So I have to mark all the. Oh no! That's like the worst comment you could possibly get. I'm sorry. I'm speaking my native language again. English only. You know the graph where it looks like periodic triangles? So how they can write the line equations for the... Really? I never heard of that, no. Um, get the standard values of the function for the specific intervals. Huh. Arctan of tan of x is just the fractional portion scaled a bit? Wait, does that actually work? I never knew that. I'm gonna miss that in a second, but the question that is, I guess, like being asked is by Tuxil or over the YouTube chat is if you have, wait, I need to reread it. I guess if you have, well, actually, wait. Yeah, Tuxil, I definitely need to like see this. I need to see it because I don't feel like I understand what's happening. YouTube doesn't allow links to be put in the chat. If you're in the Discord, you can post it in there, or you can tell me what to Google or something, I guess, and I can try and find it. Or if you're able to like somehow like evade YouTube's like linking detection, like put spaces or spell out .com or something. Hey, so 750. Ooh, Hypixel Hero, cry, creativity shouldn't die. Let us build, let us play. Stop restricting it. Is that the Minecraft thing or is that a GTA thing? I think it's Minecraft, right? I don't know. Minecraft? Oh, okay. I assume they just did something. Um, they added trash rules. Oh, okay. Alts now? Hmm. Cirrus Radiatus. Thank you for the follow. 25. You know, Jed. Sounds like Latin for something. Ah, what? Guys, I'm apparently a hacker. Who even knew? Uh, a hack? Yes, a hacker. No, true. That's a clever one. Seen you code, you're a hacker. God damn it. Ugh. It's a good roast because it's true. Oops, sorry. I've literally taken a class called ethical hacking and I got a good grade in it. But I can't say I remember a single thing about it. Would Desmos? Oops. Why do you do this to me, Firefox? I hate you sometimes. Okay. Discord an unethical hacking. Ooh. Interesting. So I use Firefox because I use Chrome for all my like personal non-stream stuff, and I just wanted any other browser for stream stuff. The issue I'm having those with Windows, trying to be smart about resizing my windows and never doing it right. It's really not Firefox's fault, but I like to blame it anyway. Chrome for school, Firefox for personal stuff. Ooh. Edge for work, Brave for personal. Okay. Edge for work. Oh my god. That's a job that I could do. For arctan of tan of x. I mean, this must have to do with the period of tangent. I bet if we did the reverse, we'd only have the one triangle in the middle, right? Yeah. Wait, why is this a line? Oh, because arctan is defined for all x. Hey, Arav. Actually, also, I feel like at least for tangent, you shouldn't have to adjust anything for x. Like, the tangent function will just take care of that. I, I'm getting confused on what you're trying to adjust. Wait, surely this blue line would have holes at pi over 2. Desmos wouldn't show it, but never mind. Same to try it for sine? Okay. Ooh. That's a fun graph. I like that. Hey, Pankaj, it's been a minute, but I do recognize that name. Um, can I help you for how to draw it? Um, what is this picture? Did someone model someone's forehead, like their hairline? Someone posted about their hairline on Twitter. It was very polynomial looking. Oh, that's kind of awesome. They got really lazy on the right side though. You made that? Oh. Well, you got lazy on the right side. That's still like a hilarious graph though. Sorry, I ooh. Oh, it does dance because of the way that Desmos renders things. That's fun. Um my scroll wheel is on. I know, I see it dancing. Or that like yeah, that's what I was looking at. Um so sorry about that. And Pekaj, I said hi to you. Did you not hear it? I I get a look at these when I say hi to people and they don't seem to hear it. Hours of internet, you'd be after this question, but I can, yeah. You can remember the graph and its intervals. You want to understand how it comes. Okay, so yeah, thank you for clarifying that. So you want to know like you specifically let me go back to Desmos. You want to know about this graph here and why it comes about. And I guess let's work it out. So this is arcsine of sine. Um, so we should have the line y equals x in our head because that's what you kind of expect when you have a function of its inverse. But apparently we do get some negative stuff that happens, and so we have to figure that out. And why would that be? So, and also sine is defined for all x. So we do expect, or sine is defined for all x, and it only gives values between -1 and 1. In the domain of inverse sine is between -1 and 1. So we should expect this thing to be defined for all x. And Artists of Internet, I said yes. Or do you mean the question I'm actively doing? The answer is yes, because I'm doing it. If you need help with a different question, please let me know what it is, and you'll be after this. I'm still trying to work out, like, the idea is you basically take this graph for sine and you make it into straight lines, following like the peaks in the values of the sine graph. That's what it looks like to me at least. Um, and I think maybe the way to work that out relatively easily is just to plug in points that are very easy. So first step, at x equals 0, sine of 0 is 0, inverse sine of 0 is also 0. So we have the origin as 1 point. And then x equals pi. Sine of pi, or no, I guess pi over 2. Sine of pi over 2. Oh, interesting. It's not. Wait. We're not exactly following the sine graph, are we? No. It goes a little higher. Hourly dose of internet for the third time. Yes, I am here. Tell me your question. Okay, so yeah, I think just plug in points that are easy. So pi over 2 is the next kind of easy point to plug in. And sine of pi over 2 is 1. Inverse sine of pi over 2. Oh, sorry. Oh my god, let me just write this out. Inverse sine of pi over 2. So I'm not doing a good job of saying it verbally. So sine of pi over 2 is 1, but then inverse sine of 1 is back to pi over 2. So then up here at pi over 2, we get another point. And since we're doing a function composed with its inverse, we should suspect that this thing is going to be a straight line. We can do the exact same exercise with minus pi over 2. Someone didn't see what real math looks like and saw the Gojira poster in the background. Hell yeah, Abomination. Welcome in. Right now we're just talking about trig functions and what happens when you do a trig function of its inverse, which is actually kind of a weird thing, but welcome in. Always nice to see another person who likes Gojira. You don't understand why it has to be a straight line? Because that one, I'm kind of doing it by intuition. If you want to really show things out, then try like pi over 4 or something like that also. But I'm kind of going off the general fact, or the general thing that a function of its inverse is equal to x. So when there isn't a weird domain and range thing happening, like with trig functions, you kind of just expect it to be the line y equals x. But then because sine and inverse sine do we have this weird domain and range thing that's happening, and you'll notice like this portion of the line is just y equals x, like just a piece of it. And so for this next piece that I'm going to work on, I expect it to be y equals negative x. Like I think the slope should always be positive or negative 1. So we plug in x equals pi. Sine of pi is 0, inverse sine of 0 is still 0. So we get that. Now if we plug in 3 pi over 2, inverse sine, sine of 3 pi over 2 is negative 1. Inverse sine of negative 1 is negative pi over 2. So then we come down here. And now we're at 2 pi. And so sine of 2 pi, like now we're just repeating, because when you're plugging things into pi, sine of 0 is the same exact thing as sine of 2 pi. So we just know we're going to hit 0 here. How an inverse of a function we reflect about y equals x. Not directly, Textial. So I guess when you're composing the two, that isn't, it's not the most helpful thing, but the same, like, it's not a coincidence that taking the inverse of a function reflects it across the line y equals x, and that when you compose a function with its inverse, you get y equals x. So that reflecting across the line y equals x thing is helpful for finding the inverse function. Here we already know what the inverse function is and we're finding values of it. But the connection with the reflecting across the line y equals x idea, let me just draw the graph assigned. Something vaguely like that. In the line y equals x, oops, it's not really a straight line. Line y equals x is right there. If we reflect sine of x across y equals x, you basically get a sine curve that goes along the y-axis instead. Like that. And y equals x is still there. The thing is that this function I've drawn here does not pass the vertical line test. Which is another way of saying it's not really a function. It assigns the same input to multiple outputs. Like I could draw a vertical line here and get a whole bunch of possible outputs. So you have to kind of make a cut in this function. And the most common way that we make a cut is go from the first positive peak to the first negative valley, so to speak. And so you get that's how we just get that shape right there. Exactly, syntax, yeah. And so that's the connection, or like that's how you use that reflecting across the line y equals x idea. I don't think it directly helps you for answering your original question of how do you graph inverse sine of theta. The only way it really helps is that it tells you that you should expect to get something that looks like y equals x when you compose these two functions. Okay, you understand? Okay. So I guess let me know if you have anything further to ask about, but I hope that helps a little bit. Awesome. Yeah, no worries. I just remember there's a new album for a band I like. I need to listen to it. I'm not gonna listen to it right now, but 42 minutes. Nice. Okay. Um, so back to this mechanics question. I'm getting part C wrong for some reason. Hey Lucas, I'm doing good. How about you? It's good to hear. What's f prime x called? Uh, well, I guess it depends. Like that apostrophe is just we call it prime, but what it means is the derivative of a function. Yeah. Very boring name. You know, I would love to hear your idea for a more exciting name. The monkey! Thank you so much for the 4 months, skeleton. Hope you're doing well. What is that emote? I've never seen that. It's a global. It has about 2 pixels total. In Dutch, it literally translates as distracted. That's weird. What's distracting about it? Instantaneous rate of change of FFX. Hey, you know that works. Syntax. The worst emote you can find. It's now my favorite. I can't even tell what expression he has. It's just kind of a face. Like, when are you supposed to use that? Afghaid? Oh no, that's an L, not an I. Af departed. Wait, that's Africans. What? Dutch. Wait, no, that you can't just change the thing that I derivative. This gets it right, at least. Wait, it doesn't say any other thing. I don't know. How do you say this? Light it? I can't make that G sound. Oh, with an N? That just means derivatives. I don't know. I believe you though. It might just be that Google Translate is too smart. Oh, no. I'm not going to show the screen because I've been tricked before with this type of thing. I assume Google Translate is giving the nice version. I assume that fucker means fucker. Oh my god. Those emotes are terrible, skeleton. You learned something new. It doesn't even what it means. Is this not dog? Dogza? Edenfokker? Is someone who breeds animals? Oh. Does Fokker not mean fucker? I'm kind of like disappointed if that's true. Oh, you know what I'm doing wrong? That's X1, not 0. A fucker also breeds animals. I guess so. You got me there. I'm a little worried about my signs here. Because I expect x2 to be past the 0 point. Let's just go with it. YOLO. Then x1 is 3 over 2 mg over k. This looks even more disgusting, if I'm being honest. Let's just go through with it, though. What about cook in Dutch? Does it sound like a funny word? God damn it. That is really funny. Ho? Ooh. Okay. Ugh. What sound does an owl make? Who? See, this is an educational stream. We're learning other languages right now. I'm not saying cock, I'm just saying cook in Dutch. Dutch man not want to start at? Ugh. I feel like I've heard that for an English speaker, Dutch is actually like supposedly one of the easiest languages to learn. Like it's the most similar to English, apparently. Even Dutch people make mistakes in Dutch grammar. To speak easy, to write not as much. Oh, funny. Let's let this thing through by 4. Hopefully we get something that's more reasonable from this, but I feel we're going to get something that's less reasonable. This actually looks exponentially more disgusting. Mooey is literally a word? A mooey? A mooey? Jamaican patois? I'm so tired. I don't even know what that means. Hair bun in Portuguese? Hair bun. What the hell? Portuguese trips me out. 'Cause I don't hear like the sounds the letters make are completely different from English, yet the alphabet is so similar. Corte de cabello? Go for Polish? The most cursed language. Hey, $10. We're definitely doing physics right now. We're not messing with Google Translate. Um, Cyrillic speaking the Latin alphabet. Oh, really? I honestly assume that Polish. What does a Polish word even look like? Oh, you know what? Maybe I do know it. That's right. It's they have some like custom or not like or they have some of their own like characters, but it is like Latin alphabet. You're right. If a language looks made up, it's Polish. I think every language is made up though. Polish would be cool to know. I apparently, or I probably have some Polish roots, or like ancestry. And this one coworker of mine, I don't know if he's actually from Poland or if he just like visited, but he knew Polish and he taught me a few words. Already, yeah, this is mechanics. It's just something I'm doing for my own like studying while I wait to see if someone pops in with a question. At some point, the earliest known Dutch sentence was a love script about someone wanting to get together with someone else. That tracks. I believe that. Wait, you better say ananas? What? Bananas? Pineapples is yuck? What are you talking about, Lucas? I like both pineapples and bananas. Not bananas. Ananas? And are those pin apples then? I don't know what an anana is. I'm a little worried this integral isn't right. I feel like it's okay. No. It's not really going to solve my issues, but I do feel like this is supposed to be a plus. Or something. Because I have an issue where if 0 is here at the relaxed length of the spring, x1 is over here and x2 is over there. No, there's no question from chat right now, no. said whatever that just was. You weren't interrupting someone else, at least. Otolaryngologist. In Portuguese. What? That's a lot of syllables. I guess it's a lot of syllables in English too, though. You like to tell me what a derivative is? Yeah, sure. This is gonna be like there's a lot to explore with like the question, what is a derivative? But I'll give you kind of like the little TED Talk version. Okay, so derivatives came about because people are interested in looking at the rate of change of things. So if you, yeah, as syntax says. What the hell? Hippopotamonstrosiquipedalio. What the hell does that mean? I'm just gonna focus on this explanation. I feel like I've messed with Google Translate enough for one day. But yeah, so people started asking, or we got interested in the idea of derivatives because if you know a function, if you know what a function is and you want to figure out the rate of change of that function, that's what a derivative will tell you. So it's a pretty classic like physics problem of you have a person standing on a platform and they fire a cannon or throw a ball or something directly to the side. And they ask you kind of like, what is the height of the ball at any time t? And you can model the position of this ball using a parabola. So if the parabola, let's pretend it looks something like that. And we only care about the positive part, but it is reflected on both sides. Yeah, Lucas, that's a good starting point. It gets a little bit more complicated, but it's a lot like that. Well, syntax, that's the entire idea of a derivative, because you let the rate, the interval of time the rate is happening in, go to 0. But yeah, the a and ax plus b is basically it. Because you could think of, if this is the position of the ball, say this axis is time, and this axis is position. If you want, say, the velocity of the ball at this time, it turns out you can draw what's called a tangent line, a line that only hits the graph at one point, right there. And the slope of this line is the velocity of the ball. In this case, tangent, I mean, maybe it's related, but don't think of tangent as in trig functions. Like, I'm not talking about tangent of an angle equals opposite over adjacent. This is a different meaning of tangent. Maybe it's related in some way, but by tangent here, I just mean they intersect at one point, like a tangent line. I'm not talking about trig. But yeah, the slope of this line, where my fists in the paper collide, yeah, at a point. The more thing is that the slope of this line is the same thing as the velocity of the ball. And so you could kind of, let me get rid of all that. So like when you first throw the ball, the line is very flat. So the ball is moving very, very fast. But the more time it spends falling, the faster it goes because gravity is speeding it up, right? So the line gets steeper and steeper because it's moving faster. And so people got interested in how can we find that equation for the tangent line. And yes, syntax, the word tangent is problematic. I'm just going to use it here and not think about it too hard because I just want to keep things simple. So if you want to get the tangent line at this point here, you normally need 2 points to make a line is the issue. So you could start with this as one of your points and then choose some other point, say like, over here and make the line between those 2 points. And that's not accurate. And that's not a bad, and that's like an approximation for the tangent line. It's not exactly the tangent line, but it's pretty close. The important thing is that for this second point, the closer it is to your original point, the better your approximation is of the tangent line. And if you let the difference between these 2 points go to 0, you have a perfect value. Akarsh, hey, you only need to say hi once. Please don't spam. And so if this is the point x comma f of x, so just any x value you want and any function value you want, the slope of that line is going to be the rise, so f of x. And so then to represent that green point I was just drawing, I'm going to say it's some horizontal distance h away from our original point. So the function at that green point, f of x plus h minus f of x over the x value, x plus h minus x. You don't know what you're getting at, but you understand? Okay, good. So this thing here is the slope of a line. It's rise over run. And we can simplify the bottom a little bit. And what I was saying before about the closer this green point is to the original point, the better. Calculus gives us a way to express that in math terms, which is using limits. So you take this thing, and we're taking the limit as h becomes 0. And that's a little bit of a separate topic of how you actually evaluate this expression. But what this limit thing does is it basically makes the distance between these 2 points 0. And that's why it's an instantaneous rate of change. If you have x squared equals f of x, that would be x squared plus h, or that'd be x plus... the second thing you said, x plus h in parentheses squared. So yeah, if your function is f of x squared, you could find the derivative by evaluating this limit here. x plus h squared minus x squared over h. And so like kind of the things that this limit does is we want to plug in 0 here, but we can't do it right now because we're dividing by h. Or sorry, we want to plug in 0 for h. That's what this means. But we can't plug in 0 for h immediately because we would be dividing by 0. So we have to do some extra math first. And so I don't want to go into how you actually like do this yet, but or maybe syntax wants to go there. Akarsh, looks like a crazy limit you have there. Let me we go a little over limits. I never did the epsilon-delta of my school, just given the rules we're allowed to do limits. I don't know how one would derive those rules. Yeah, we can talk about epsilon-delta. I'm not very strong with it either, to be honest, but we can try and talk about it. Let me take a look at Akarsh's question first, because I just want to see if I can figure out quickly whether I can even do it or not. So greatest integer function is like floor. Uh, relatively slow Fenbox, but nothing too crazy yet either. We were just talking about what happens when you compose like trig functions and their inverses, and how like sine of arcsine of x isn't always equal to arcsine of sine of x. So we had a pretty cool discussion there. But I get that out of your sight. Yeah, I'm trying to quickly see if I can get an idea for this limit problem here, Silverbird. It was posted by a Karsh in the YouTube chat. It looks a little difficult, and but then after that, I think syntax error and maybe Lucas want to talk about epsilon-delta limits. I kind of want to plug this into Desmos. Do you want to? No. Yeah, that's fair. I don't want to talk about them either. I'm gonna go to Desmos because I think I could spend forever on this. I'm just gonna say 0.5 for lambda for now. What? Well, yeah, I said A has to be between 0 and 1. I guess we can make that happen though, right? I guess we can make it a 0.05. So going between 1 and 2. Oh wait, R minus. Oh, I misread that. It is R minus 0, 1. I did the exact opposite of what we're supposed to do. So I don't think this limit exists. That was my concern with seeing a floor function in here. Well, oh wait, well, okay, a crush was on say given the limit exists for both left hand and right hand. The over like they don't agree though. It looks like they're approaching something. Like I guess they're both gonna approach 0 for large enough lambda. Or maybe 1. No, okay, so for large enough lambda, they'll go to 0. But the overall, I guess we're... What is the... Oh. Yeah, that's a weird function, Lucas. Some specific nice lambdas that make it work? Maybe. JD, I think it means set subtraction. It's all the real numbers except for numbers between 0 and 1. Is how I'm interpreting that. Yeah, Silverbird. That seems to be what's happening. It doesn't seem like it exists to me either, unless what as Finblock says, there's some special lambda that somehow saves it. Except for 0 or 1. Oh, ooh, no, yeah, that's you're right. For whatever reason my mind just is blanking on this, but yeah, it's any real number except for exactly 0 and exactly 1. It can be between or outside of those two numbers. Positive arbitrary small x, it's going to ABS 1 over lambda. For negative ones, it tends to ABS 1 over lambda minus 1. Not in? I don't know. I think this is the best way to put it. I think not in would be weird. Freddy, what property of logs are you talking about? How x to infinity would it look straight at infinity, or look like y equals x? It depends on, well, yeah, that's LaTeX. Uh, more or less. Well, it's not exactly LaTeX. The slash lambda means the symbol. It's like one division sign, and then in LaTeX you do the other slash lambda to make a Greek letter. So Silver is saying 1 over lambda. It's an equation for capacitance from physics AP exams. That helps, but I I need to see what the actual question is. Um, yeah, Akarsh, this question might not be possible. And if it is possible, it's not easy. I don't know that I can help with it. Okay, thank you for Freddie. That helps a lot because it was a little bit hard to figure out what you wanted. Um, okay, so let me try and rearrange this equation for Freddie quickly. This limit one, I'm gonna move on from unless someone has an idea for it, and then we'll talk about epsilon delta limits. So Freddie has this equation. Looks like it's about an RC circuit. And you want to solve it for T or RNC. And yeah, Lucas, I'm sorry. I didn't quite understand what you're asking with that. If you want to talk about it more, I can try to figure it out. But so first, let's start by isolating this E. So I'm going to divide the capital E over. And then subtract 1 from each side. Now multiply each side through by -1 to get rid of that negative. Okay, and so now from here, we want to solve for this like T over RC thing, but it's trapped in the exponent with E. So what you do is you take the log of each side with the base of E, or whatever your base happens to be, but we have E here. And a natural log with base E, oops. Oh my gosh, I'm writing this terribly. A log with base E is the same thing as ln. So I'm going to take, yeah, exactly what you're saying. Ln of E is 1. So I'm going to take the ln of each side. And we can use log rules to bring this exponent down in front. And then we have just ln of E is 1. Hey, LTO Aldo. And hey, Maxi. So ln 1 minus V over E. That looks like, oh, that looks like the charge of an electron. This is a different E, Lucas. This E is Euler's number. Minus T over RC. Yeah, 2.771 as Maxi says. And so from here, you might know how to, whatever you want, T, R, or C, maybe you know how to do it from there. But yeah, that's how you deal with using logs to solve for T or RC. No worries, Freddie. Thank you for the question. Okay, so epsilon delta limits. Yeah, that's even easier than Freddie. Just divide by capital E and then do ln immediately. I was saying lambda is a half would give you a limit of 2 for that previous one. Hmm. Yeah, the one we were doing before, and what's on the screen right now is calculus. So, you can only, you said you're, or it sounds like you're doing AP physics. If you have an AP physics class available, you probably also have an AP calculus class available. It's normally a college level class though. Okay, see you soon, Lucas. Normally for like an AP calculus class, they don't make you do something like this is a little bit of a famously difficult definition to learn. They normally don't make you learn this, but like in a college course, they might make you do it depending on the professor. AP calculus easy. Nice, nice. Actually, okay. Lucas doesn't want to talk about this syntax error. Do you want to talk about this epsilon delta limits? I'm pretty rusty on them, but I should be able to remember how to do things with it. You'd like to know? All right. Um, so the entirety of an epsilon limit is that someone gives you an epsilon greater than 0, and it's basically your error tolerance. Be able to bully them in the future. There you go. uh, so some third party gives you an epsilon and says, "I challenge you, like within this error tolerance that I give you, that you should be able to name in the error tolerance is for y is for like values of the function. You need to be able to name an error tolerance for x values such that every single function value is within the error tolerance. So you're given an epsilon and you have to name this delta that supposedly exists for a limit to exist. Well, yeah, that too, Maxi. Um, so that's kind of like the fundamental idea behind what's happening here. To be honest, I tend to remember this definition of the epsilon delta more that uses all the quantifiers. Uh, let's bring it into a journal. Plus plus. Let's see if I can remember how to do this without any preparation. Hey, Ruskiny over on YouTube. I don't know how to pronounce that. You're pretty behind with math. Do you think it's probably to finish the second half of Algebra 1, Algebra 2 by July? How much time should I put into math every day? That definitely sounds possible to me. Um, and how much time you should put into it is kind of like a personal thing. Like you need to avoid burnout. Um, and so I don't know, like getting to a schedule that works for you. You kind of have to experiment with it. Um, like try to go for an hour each day and give yourself a rest day each week or something like that. But like, yeah, it's hard to really say. Epsilon delta, I mean, it probably comes up in vector calculus too, but it doesn't have to be in vector calculus. Oh yeah, that could really help. Just doing it at a community college. It's nice to like, because that like makes you like stay on track with things. So Syntaxer, you want to send the really mathy explanation? Like, do you understand what like this stuff with the quantifiers mean? Or even like the if and only if piece? Yeah? Okay. Um, I don't know why I'm rewriting that. Um, how do we do this? So let's say we want to prove. The question is to prove that the limit as x approaches we can do it like arbitrarily. Doing it for parabola, I remember there's some weird stuff that happens there, so I want to avoid a parabola. Maybe we'll just use a line. X approaches C of f of x equals mx plus b, maybe, is mc plus b. Basically, we're proving that for any linear function, the limit is going to be just the result of if you plug in your limit for x. And in theory, you would do proofs like this for every type of function you want to take the limit of. It also proves that a line is continuous, yeah. You know what, Kit, can I look through, does Zach still have the reanalysis 1 stuff posted? Oh, it looks like it. Like, what were some of the things we were doing then? Because you're right, this would also prove continuity. But I remember doing problems like this. Is it weird to say it? Also, I'm trying to work it out for myself, to be honest. I need to go earlier than that one. Ooh, hey, okay. The statement is continuity. I'm getting this from when we were first working with epsilon-delta limits in Zach's class. This is the type of question that we were doing. That's why I'm going here. Like we did number 5 right there. We didn't do like generically like I was saying we could do, but like what this is just kind of how you like, we can fill in the numbers if you don't like to do it generically, but this is basically like what you would do for an epsilon delta proof for a limit, is it not? The work isn't organized the best because I think this is me and Obi. We're just like working this out. Like live. Okay, then let's just take this problem exactly and do that. And let's do this. Basically that, Freddy, yeah. Like they give you the output tolerance and you have to find like the input tolerance. Um so based off the definition, um we want x minus 6, the absolute value of that, to be less than some number delta. And we want the absolute value of f of x minus our proposed value for the limit 1/2 to be less than epsilon. And we okay, yeah, so we know more things about, or like we have more to work with this f of x statement. And so we're just going to start with that because like there's not much that we can do. We want to basically find a function like given an epsilon, how do we choose our delta? And so let's start by mixing around this statement with epsilon and see if we can find a delta somewhere in here. Well, we'll leave that there. Linear equations in two variables just for some practice is a bit confusing. Yeah, sure. If you can like point to a specific one that you find confusing, or I mean, I can even talk about them in general, but if there's anything specifically about that you want to hear about, like let me know. So the first thing we should do is plug in our f of x. It's 1 over x minus 4. And then, you know, we're still just like playing around with it. We're hoping to find an absolute value of x minus 6 somewhere in here so we can involve delta. So we can get a common denominator for these two numbers. My delta always trying to get an epsilon's business crazy. Yeah, super crazy. uh, and so then we get what, 6 minus x over 2 x minus 4. All right, see you, Freddy. And so now we have a 6 minus x here, and it's nearly like the x minus 6 up there. So we can use some absolute value properties and split the absolute value up into each of the fractions. And we also know that the absolute value of 6 minus x is the same thing as the absolute value of x minus 6. And you know what? Just because it's annoying me, this 2 can come outside the absolute value because it's a positive number. And so now the absolute value of x minus 6 is less than delta. So the inequality is going the wrong way right now. We can't just replace this x minus 6 with delta. Because this inequality goes the wrong way for that, doesn't it? You hate how it uses the other epsilon? Yeah, I do always think this type of epsilon means, like, in for set notation. Wait, Ben, that's the thing we're doing, like, right now. Yeah, I was like, um, the actual principles behind it. Let me finish up this because I think we're towards the end, and then we can, and then I'll like back and talk about like what it means again. Um, how do we deal with this again? This part was a weird one. What do we do here? I don't understand our work. This is from like a year ago. Why did we randomly put in a third? This is the I guess we're yeah, Maxi, as you say, I guess we were. Epsilon equals 1/6. This feels so random though. Uh damn it. I thought this would be more clear. I hate this shit. Um why is the inequality going the wrong way? Hmm. Should I have chosen an easier function? I remember trying the second one for this one that I was going to do, or like I remember trying this one and I couldn't figure that one out either. And so I was trying to use a line in my original example and doing it generically. So like it is continuity, but you can show that with epsilon-delta, and I don't know. The delta at minimum 1. It seems like what we did in the work. But like, if we pretend that x minus 6 is less than 1, I don't get what this does for us. Oh, that's right. It's, oh, you think about stuff like that. Um, if x minus 6 is less than 1, isn't x minus 4 less than 3? Yeah. Um, I forget how you use this though, dude. But basically, if you pretend that delta is equal to 1, you get this thing is less than a third. I don't get why this lets you conclude that delta is the minimum of 1 in epsilon over 6, though. I shouldn't have chosen this as an example, because you have to do some really tricky stuff with the absolute values here. that I don't fully understand. It would have been better to use something simpler. Like, I should have just stuck with a line example. Ideally, you can just use this fact directly and plug it in somewhere. But for this one, you can't. You have to do some weird stuff with the absolute value stuff. Oh, why freaking journal plus plus? I need to see. I need to figure out why that happens. That's easier? That's limit to infinity, which is a little bit different. Wait, like you're saying you need to show the limit as x goes to infinity of sinh of x over e to the x with epsilon delta? I need to find the definition for when it's to infinity. For the one that I have up here, I think it needs to be a finite number. It's the easy one. Oh god. You also have one with anch or than, however you pronounce it. Oh my god. Okay, wait. So I kept someone on YouTube waiting for a while. Rusting, or like the person who want to talk about linear equations in two variables. Are you still here? Because this is gonna take me a while. The more that I look at it. And I can hopefully talk about their topic a lot quicker. Yeah, I'm sorry, syntax. I chose a bad example there. Um, I probably should have chosen this book's example. But like this has a pretty good like picture that kind of explains that error tolerance idea, that the epsilon is your error tolerance for the y's, and you have to choose an error tolerance for the x that gets you the epsilon that you're given. I don't see that person replying. Oh, so you can make it just a constant minus e to the minus 2x? Okay. So, I mean, we'll still try epsilon delta on this one from Ben, but it's going to be pretty freaking annoying, I think. So sinh is e to the minus x minus e to the minus x over 2. E to the minus 2x, I think, Maxi. Hey, color cone. Okay, so allegedly this equals a half, but we have to prove it using epsilon delta. For all epsilon, let's do the other epsilon, greater than 0, there exists a delta greater than 0 such that absolute value of x. Oh, I see. Okay, this is where I need the other. This is where I need the definition for limits to infinity, because this doesn't make sense, right? I haven't done this one before, but I assume it's not going to be that much different. This is the result being infinite, but I want x to be infinite. Here we go. Oh, is this hard to read on the stream? Oh, wait. Oh, no. Okay, never mind. You meant the feedback is hard to read. Okay. You're right. That is hard to read. Oh, it looks basically like what we're looking at now, though. Maybe. So here, if there exists in n greater than 0 such that for all x greater than n, his name is spoken. Oh God. Uh, I think it's not. I mean, I think I'm getting this part of it slightly wrong, but I think like this. That was my first year project, which was on quantum information theory. Oh, you're right. You mentioned that quantum information theory thing. A spoken exam sounds terrible. Um, okay, so basically, we need to be able to say that this function gets arbitrarily close to 1/2. At some value capital N. Can we just solve this for capital N? That might not be too bad. L is the proposed limit that we're saying is 1/2. You just have to like know what L is from whatever other like, you know, from this stage. You probably use intuition to figure out the limit is 1/2, and you have to use that intuition to know what L is. Nothing about this proof tells you what L is. You have to figure out what L is like separately. Um, yeah, exactly, and that's perfect. because this proof does not help you find L. You have to know L through other means. Okay, so e to a number is always positive, 2 is always positive, so that negative sign can just go away. I think we can just solve this for n. And that's going to be our choice, or that's going to be like how we choose n. So like the point of this proof is that you need to be able to the limit is going to be a half. I don't know what the curve looks like, but if that's x equals y equals a half, and the actual function looks something like that, if they say tell me where the function is within, say, like 0.25, you have to be able to name a cutoff point in terms of x, after which the function is always within 0.25. And so that's why we're doing this kind of, we're trying to find what choice of x gives us that, and we're calling that cutoff choice capital N, just because that's, or that's what I'm calling, because that's what the website used, but yeah, Finbox. I think that this actually could be a lot, like, this one's a lot simpler actually than the one, I thought it would be harder, but I think this one's actually simpler. So we can take ln of each side and not mess up our inequality, I think. How am I deleting terms? What do you mean deleting terms? Like these 1/2s? Or the absolute? Oh, okay. I took out the absolute value. Oh, I messed up. Okay, sorry. I multiplied each side by 2 in that step, but I forgot to put the 2 over there. Let me back up though. The absolute value bars can go away because e to a power is always positive. 2 is always positive. So this thing here is always positive. So we can safely just take away the negative sign and get rid of the absolute value bars. If it's sometimes negative and sometimes positive, then you have to worry about it, but not here. And from here, we get to just solve this thing for n, basically. Because for any epsilon we're given, we need to make a choice of n, so it makes sense to find n as a function of epsilon. So multiply each side by 2. Then we can safely take the ln of each side, and I don't think that messes up an inequality, because it's monotonically increasing. This playlist is looping. 1 second. Okay. So ln of 2 epsilon. And then now we just divide each side by -2, which does flip the inequality. So in theory, any choice of n that's greater than this number here works. If they say, name me a cutoff point where you're always within 1/8 of your proposed limit, you can literally do -1/2 times ln of 2 times an eighth and get your choice of capital N. If you have the ln of monotonically increasing, obviously the fact that these monotonically increasing bounding above. I'm not sure that helps. Do the actual like epsilon delta thing. Or maybe you're trying to skip over the epsilon delta, but we were asked to do epsilon delta. Yeah, uh uh, yeah, Ben is learning the math in Danish, so that makes the translation hard. I assume pairing means pairing a delta to an epsilon. I'm not sure what the which pairing problem means though. Yeah, I mean, you can probably just rename this capital N to be delta. Actually, is this even... Do you need that to be... I don't think you need that to be bigger than 0. It's an actual x value here. No, wait, apparently you do need to be greater than 0. It's weird. I'm putting it back, but... Um... In epsilon n proof. Hey, Phobos. And hey, Papadoria, approximation question. Oh, geez. That's a weird one. I'm kind of knee deep in this limit problem, but I think you would be right after. Hmm. Um, do they have a picture for this? They do. That's not that good, but uh, you're naming the cutoff point in x after which um the entire function is within the error tolerance that you're given, which is epsilon. So they give you an epsilon that is basically saying the function is allowed to be like the limit plus or minus epsilon away. And you have to be able to name an x value where that happens for every value of x after that. So that's why we try to find this big N as a function of epsilon, because you could be given any epsilon, and your choice of n is going to like depend on how strict they're making that error tolerance. And the idea is that that epsilon value could be really close to zero, like 0.000, like, you know, tens of zeros and then a one. So it's getting arbitrarily close to the limit. And you can actually name a value n where that'll happen. Yeah, so your class might be using different variables or different like names for the same things. But either way, like n or delta is going to be your cutoff point. Um, and so there is like a second piece of this where I don't. Some people say that you need to like. This is just like an exploration thing that we've done here, and for the actual proof, you now need to actually like go back through and plug in your proposed value for n and show that it actually works. But that kind of depends on the class, to be honest. But it's a great. Oh, thank you, Phobos. So I just put it onto the radio of a song that I like. So this is for a separate function. Uh, oh, for the one with than. Okay. Uh, yeah. So if this is limit as x goes to infinity, minus 2 over e to the minus 2x plus 1. Yeah, it's because it is weird to have e to a negative power in the denominator, but I would still think about it as it's e to the power of a very large negative number. And that goes to 0. So I would say just that little piece there is 0. And then let the rest of the chips fall where they may. It's not that like the plus 1 messes up your logic entirely. Let me rewrite it in a different way. This e to the minus 2x, you could write it as a fraction, like 1 over e to the 2x plus 1. But it can't flip back up to the top because of that plus 1. If you want to get rid of the negative power, that's what it would look like. No. If you want, you could multiply this thing by e to the 2x over e to the 2x and get something that might look a bit more familiar. But yeah. We're from very big if x very small. Plus one stops at... Yeah. Yeah, it should be the same like a similar process as we did up here. I think. Yeah, I think it's the best that I can do for you. Like, I might be able to be a bit more specific if you like send an example. Oh, why are you doing this to me? Ugh. Like if you want, you could send an example of like one of the proofs that you're supposed to do, even if it's in Danish. We might be able to figure out what's happening. But if you think you got it, then we can just leave it. Um. Okay. 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 Papadoria. Let's look at your question then. Sorry that took a minute. I don't immediately know how to do this. Well, I have part of an idea. Ah. Like, could we define an error function and optimize it? Did that oh my play? I don't know if it played and wasn't paying attention or if it didn't work. It did for you? Okay, good. Oh my. Um that's kind of a funny question. Tangent and arcsin do look kind of similar on this interval. All right, thank you, Jed. Both of them are positive, so we don't even have to do anything like squaring or anything like that, I don't think. Fx to the d tan x minus arcsine x. Oh, you're back? Okay, nice. The limit? Kinda, yeah. I don't feel very confident in it, but I think so. My idea here, Papadoria, uh, all right, sounds good. Sleep well, Ben. Thanks for trying to think. Yeah, epsilon-delta proofs, I'm pretty terrible at. Like, I feel like I only half understand them, so yeah. Can we treat this as a multivariable limit? Like that's what I wanted to, or a multivariable optimization problem. First, I never explained them. We just do them. Oh, that sucks. Yeah, you might have more luck asking like Zach or Eats Its Way Pie or Penn Center. Um, I'm pretty weak on them though. Uh, I don't know color cone. I was just gonna make up a metric like this here. This is all the context that we have though. A Rubik's cube. We can do a Rubik's cube. Scramble it up. Oop. I was just hoping to take the error function and do multivariable optimization. I don't know exactly how that would work. Like, would I treat x as a constant? That's what I was hoping I could do. All right. Scrambled. Inspection. Do, 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 do. The world record. The world record is like 3 seconds or something. Something stupid like that. Ah, not a very good solve. Oh well. My PB is like 17 seconds, and I said that in high school, and I think I've been washed up ever since. Um, yeah, I'll see you then. Great, MF. Yeah, absolutely, Cameron. Feel free to type your question out there in chat, or if it's easier to put a screenshot, I can put it in my Discord. I don't know. If we treat x as a constant, though, the arcsin is going to go away entirely. That can't be right. Um, I mean, could we just do it, I guess, in 4 dimensions? We'd get a lot of partials, though, wouldn't we? Dora the Explorer. Theory of tan X and arcsin C kind of similar. Oh, that's an idea. Let's explore that. Thank you for the follow. Oh. Why is tangents expansion so dumb? Triangular numbers? No, no, they're not triangular numbers. They're tangent numbers. Okay. I mean, we don't have to. I guess we do have to over the coefficients a little bit. Oh, that's arcsin. Arcsin is up here. That's, oh my god. This is honestly still the best bet, I feel like, though. Yeah, so the person who asked this question, Papadoria, normally has pretty nasty questions. That's not surprising to me, at least. Um, one is alternating, the other isn't. Yeah, this is. I like the idea. This is a little too complicated for me though. I don't know how to go about comparing these. Finish it quick. Oh, nice. So yeah, my only other idea is to try the multivariable calculus way. You think you did it correctly? I I couldn't tell you firmly for what it's worth. So wait, this is alt. Oh no, the triangular numbers are or the tangent numbers are alternating, but this undoes the alternation. Is that what's happening? Disgusting. Um. Yeah, sure, Ben. It's just disgusting. They're called the tangent numbers apparently in that table. Apparently, this is how they're defined. You see the patterns in the T? You saw that? Wait, let's try and quickly look at Ben's thing. Can I rotate this, please? Please let me rotate it. I don't want to tilt my head. Is there no rotation tool? Come on, normally it's a little... Like up here, there's a little like rotation thing. Nah, right click doesn't do anything. Uh... Why can't I delete the image? There we go. Still in the upper left? Oh. There's that X box. Is oh, that deletes it. On the right? I don't see it. The little red square just deletes it as far like that. You feel I feel betrayed too. In this pain for life, apparently, yeah. God, I have to use the bathroom so bad. I'm sorry, Papadori. I was just trying to like quickly like check through oh my god, dude. Okay, I'm gonna put the image up, and then I'm gonna go like make a new hole in my toilet. Um, and then I'll check it after. And then Papadori, I promise I will come back to your problem. I was hoping to do this quickly. Be right back, guys. Okay. I was indeed doing the PP dance. Also, you're blue now, Casey. Um, what's going on here? You get a common denominator. So the cool kids we're doing, yeah, fair enough. Oh, I could feel that color change. Hey, Electric Geek. Um, oh, I see. -2 +2. Okay. And then everything that result is a positive number. So you can get rid of the absolute value bars. Ooh, that does get a little bit annoying, doesn't it? Are you... I don't know how you went from this step to this step. I would just send like 2e to the -2d. Like I probably multiply it through by e to the -2d over e to the -2d. Or I guess you can do e to the positive 2d. And get 2 over 1 plus e to the 2d is less than epsilon. And then probably flip each side. And that's a little bit easier to solve for d now. Like that. We get near the same thing. I get an extra -1. The sine rule comes from? I don't know exactly how you get that offhand. Oh, wait, yeah, we do have that inside flipped. Yeah, that is an important difference. I don't know how you got this, though. Like, we can't, like, if you're letting d go to infinity in this step, which that seems like maybe that's saying, like, I don't think that's a good thing. Um, oh, you let only that e to the -2d go to infinity? I think that's a bad step. I don't think you should be taking a limit to infinity as you're doing an epsilon delta proof limit to infinity. I don't think that's legal. I think I would do the thing that I wrote over here. Because you're just defeating the purpose of doing an epsilon delta proof. Okay. Um so yeah, no worries, Ben. Electric Geek, where does the sine rule come from? I assume there's a good explanation somewhere. Oh, it just comes from dropping, like you can think of any triangle as kind of two right triangles like side by side, like they drew right here. And the law of sines follows from taking sine of each of these smaller right triangles. That's kind of neat. I never actually knew that. So yeah, I would just look at this. Electric Geek. Okay, so Papadori, to your question, I was trying to avoid doing the multivariable thing because you have to get every single second partial derivative. Well, no. If you want to classify it, you have to. We can just get away with not classifying it though, right? We can look only at the first partials. I'm gonna call it capital E. I guess let's get the three first partial derivatives here and set them equal to 0 and just see what we get. I chose the hard one first for some reason. Fx to the d secant squared x. Actually, wasn't too hard. dd. Ooh, so that's like an exponential, isn't it? Is it just ln x? Like if you take the derivative of 2 to the x, that's 2 to the x ln 2, right? Yeah, it has to be, because the derivative of e to the x is just e to the x, and then you multiply by ln e, and that's 1. Hey, famished. Math, it's all the same. You agree too, Papadoria? Okay. So for all you, I don't know why I'm doing parentheses there, but not there. So what you would do here is set each of these three derivatives equal to 0 and solve for your three variables for x's on that interval. That doesn't seem like the easiest thing to do in the world to me. I guess from this equation here, you would get only x equals 0, right? But, well, that's, I don't know if that's a good thing or a bad thing. That breaks this derivative down here. This does not seem like the way. Well, but the I'm finding the minimum in theory of the error. Um, the function we're optimizing is a function for the error in theory. The thing is, like, I feel like we should like I want to treat x as like a constant in some way. Uh, no, Jed, that doesn't help because we're restricted to this interval here. So no matter what our choice of f and d are, x equals 0, they are going to exactly match each other. Like, can we make their derivatives match? Like, instead of doing this multivariable thing, can we keep it single variable? Um, Berber the big boy, thank you for the follow. Hello. Like, can we make their derivatives match? Question mark. Well, you have to do it at every point though, so I don't really know how that works. No, I have no clue. You're welcome to use it, AI Dora, if you want, and talk about it. Um, as a personal choice, I don't really like using AI for myself, but people are definitely like allowed to, if that's your question. What game is this? This is the worst game of all. It's called math. So I think, yeah, Territar, like least squares is what came to mind at first, but everything was always positive, so I was wondering why I would even need to square it. Um, Minimize the L squared norm of the E. I mean, that seems like a reasonable thing to do. It just seemed like it'd be harder if we like this thing seems like a harder function to optimize than the one I had written initially. Oh, I think this is the more common thing to write. I just noticed that the functions are both positive for this interval, so I don't know what the gain is in squaring each of the terms. Oh, that's true. You don't need to take the square root. But I feel like aren't we going to end up in the same like kind of general boat as we were just in when I was trying to do before? Oh, you love math? Oh, nice, Berber. To be honest, I was just kind of like memeing when I said that. If you're not aware, there's a little math niche over here on Twitch. So if you're interested in like more math streams like mine, there's a whole list of people to get you started. There's even more than that in general, but those are the ones who I've known the longest and can like recommend the most. You're also like welcome in here too. Whenever I see a new phase, I just like to let people know that this niche exists. You don't square them individually, Territar? You do the entire thing squared. Hey, Goofy the Ultimate. Thank you for the follow. Y partition minus y actual squared. Okay, fair. But so I could take all the partial derivatives of this, but aren't we going to get basically the same thing as I had before? Like, we're still going to get stuck somewhere, I think. Goofy, could you give me an example of a problem with logarithms that you're stuck on? Because there's like a lot of different interpretations for that. I'd be happy to talk about them, though. Mm-hmm. Thanks for that color. Yeah, so if it's easy to take a screenshot, you can also oh, you're doing so you can hop in too, but um it's easier to take a screenshot, Goofy. You're also going to hop in the Discord and post it there. Um Oh, if you want to post one color cone, I guess in like math discussion. This is the L2 norm on 0 to pi over 2. Huh. Hey, Zach. So, do you integrate this, or what do you do with this? Or you're optimizing this? Aren't we gonna get something that's terrible? Goofy the Ultimate, log base b of a equals 8x. What's x? So log base a of b equals x squared. Let me talk about Goofy the Ultimate's question about logs. This I don't know. I never done this L2 norm before stuff. This L2 norm stuff before. What math? Oh, this. You, I don't know what you would call this type of math. Optimization of some kind. Like we're using. It's gonna rely on some advanced like calculus stuff, I guess. Um, Call it hard. Yeah, same. Take partial derivatives inside the integral? I don't know what you're going to do with them after that. So if you're solving this for x, Goofy, this is log base b of a is just a number. You'll just divide each side by 8 here, and that's your answer for x. It's in terms of b and a, but that's the most we can do. Oh, system of two equations? There's 3 unknowns. Wait. Oh, so you're... Oh, wait. Log base a of b is x squared. So I gotta play around with this one. This is weird. Territory. That's the first thing I tried, but then you get stuck, or at least I got stuck. All right, if you did with the integral thing, I don't know how it's going to be different. Papadori is suggesting this identity, but you're maybe not sure of it. I'm okay, Cytos. How would you prove that identity? Like just do change of base? Log base a of b is equal to log base b of b over log base b of a. Okay, yeah, so I agree with that identity. Okay, so maybe that's the key here. I'm going to take this equation here, and I'm going to make the log base a of b into log base b of a in order to match the other equation. So there's a thing called the change of base for log, where if you have log, let me do completely different letters, and I'll do it up here. If you have log base m of n, you can rewrite it in some other base completely. We'll say p with this identity. Log base lop p of m. And so if we have log base a of b, and we wanted to get it in base b to match this log over here, let's apply the same exact identity. Log base b of b over log base b of a. But log base b of b is just 1. So we found that log base a of b is 1 over log base b of a. So I'm going to plug that into this equation over here. You could do the opposite with the second equation, but I'm just kind of randomly choosing the first one. It's equal to x squared. And now I'm going to flip each side for a reason that'll hopefully be clear after you see the next step. So we know that log base b of a is equal to 1 over x squared, but we also know that log base b of a is equal to 8x. So 8x should equal x squared in order for these two statements to be true, right? Just equate them. So I'm sorry, it's 1 over x squared. And so now from here, we'll just solve this for x. Yeah. Yeah. It's really easy to make mistakes with this. I guess to solve this for x, we would multiply each side by x squared to get rid of the denominator. So we get 8x cubed equals 1. Divide each side by 8 to get x cubed equals 1 over 8. And then we take the cube root of each side. And I'll kind of write out how you simplify this. When you have the cube root of a fraction, you can say it's equal to the cube root of 1 over the cube root of 8. The cube root of 1 is just 1. The cube root of 8 is 2. So I say x equals a half here. Yeah, it's kind of a weird problem. I've never seen one quite like this. But yeah, as a way to play around with the log identities, then yeah, you can eventually get there. So that would make sense. Thank you for the question, Goofy. Territory, is a numerical solution to the optimization problem sufficient? I guess it's up to Papadoria. I would have trouble doing anything at all with this integral too, so I don't blame you. Set myself in the foot. Yeah, this is it's a weird one. I did see the question from Cytos, and I have no inclination to actually do it because I have no clue how. Oh, this is a challenge problem? Yeah, it's pretty tricky to figure that out, especially if you're new to logs. Explain differential equations to me, please. I think you could study them for multiple years and not understand them all. If you have a specific question, clarification, feel free to let me know, but that's way too general. Done with the easy logs? I don't know. But yeah, Goofy, I don't know, did I link you to it? Maybe not. In case you run into more math questions in the future and I'm not around, there's a whole math streamer niche on Twitch. So whenever I see a new face, I like to let people know that we exist here. Um, so if you're in need of more help, then all people do math help also. Factor x to the 4 plus 4 without imaginaries. Is that even possible? So sum of two squares. Maybe because it's a quartic, it is, but I don't know. Hey, Bubble Boba. uh, if you're talking about this stuff here, I have no clue. I'm completely lost in this problem. If you're talking about this stuff here, it's a really weird logarithm problem. But I'm also terrified by the stuff that's up here. My Twitch is the same name, Clarination. I think I have a command for it. Yeah. But yeah, like with this question that's on the screen right now, I'm hoping that someone in chat just carries me. That I'm just stalling for time here. Use deep search with GPT-04 and it used the L2 idea we had and used numerical integration to solve it. It got F is about 0.9 and D is about minus 0.07. Not very insightful though. All right. It's interesting to have that as a reference point though, Dora. I'll copy it over to the YouTube chat. In case, as like a reference point for those numbers might be. B to the 8 x cubed equals b to the 1. Yeah, Dora, that's true. Wait. B to the 8 x cubed equals b to the 1. I don't know where this is coming from. But if you know b to the 7x cubed equals 1, yeah, you could relate these two equations with each other. I don't see why not. B to the 8x squared. Yeah, I mean, in theory, if they're both equal to 1, like you can always relate the equations to each other in some way. I'm not sure where it's coming from, but yeah. Oh, thank you for spelling out the acronym for me, Gold Rail. AP Human Geometry, or Geometry, probably Geography? I never heard of that class. What is it about? Huh. That I never heard of this class before. It seems kind of interesting. You could that I yeah, there is one history streamer who I know of. You could try dropping in. He does some office hours streams where you could try dropping in on him. Shane McInnes. I really like his stream. You could try him. And look for when he's doing an office hours stream in particular. I don't know like what depth he'll go into. Like you might want to just try and keep it more like conversational. But that's like the best person I can think of to try. I can't promise like I I don't want to promise things on his behalf though, but that's the best person I can think of to try. He may just want to give like, I don't know. He might go off on a tangent and really answer the question thoroughly. He might give you like, he might point you somewhere where you can like look at. But that's the best person I can think of to at least try with that. Thank you for the follow. Wow, there's been a lot of new people here. For the people who are new, I do dual stream to Twitch and YouTube, so if you hear me talking to someone who's not in the chat that you're looking at, that's probably why. Jed is saying that equation came from one of the other equations. Those are the YouTube. Right now I'm live on the math YouTube one, that first link. Is the YouTube more delayed? That's annoying. I haven't actually tested that. I have the YouTube set to the lowest delay it lets me possibly do. So I don't know why that would be happening. It's interesting to hear though. Oh yeah, the Colette's conjecture problem, Piggy Master. Step problem so difficult? Like involving the step function? Yeah, those problems get really crazy. I don't know if you mean step problems in some other sense of the word though. Yeah. That was a really funny realization because it's genuinely like clever too. I think we Googled it and I couldn't find anyone online who found that same equivalent statement of the Colette's conjecture. Cytos, Piggy Master was given the Colette's conjecture as a challenge problem, but it was disguised in a way that didn't look immediately like the Colette's conjecture. It's probably still in my Discord somewhere. Oh wait, no, you post things just in the chat. You're not in the Discord, are you? It was some. It was something like a sub n plus 1 is equal to... I already forget, but it was sine of something times something else, and there's a quotient in front. Or if you can type it there in chat. I don't know if it's even important, but... You don't have to join the Discord if you don't want either. It'd be fun to just like see it again, but if you don't have it like handy, then don't worry about it. I am curious to look at this Desmos that Territar made, and that's a clever way of avoiding the YouTube linking issue. Just giving the last string of characters. Oh, never mind, I did it wrong. Am I missing a prefix? Or like a part of the link? Oh, slash calculator. There we go. I gotta know. Yeah, I forgot this was a com slash calculator part, like the slash calculator. Oh, is there nothing actually happening visually? Symbol gradient descent implementation. Oh, okay. Called step papers. Oh, I haven't heard of those then. Uh, ax to the b tan x and arcsin x. Let's make this a bit simpler. Did I mess up the interval? Wait, arcsin isn't defined between 1 and pi over 2. That's a bit of an error in the question, right? That is pretty freaking close, though. Yeah, that is close to the ChatGPT numbers. That's neat, Territar. Thank you for making that. The choice of function is kind of interesting. Like, why a polynomial times tangent? If you're asking me what I would rather do, or
What do you mean?
I would take either. I guess I'll lean towards pure math. Drum roll. What time is it? Okay, we still have a little bit of time. Oh, and actually, while there's some downtime, and because I just remember now, we hit 1,000 subs on YouTube. So I just want to say thanks to everyone who's here on YouTube. It's a big milestone. Actually, we're up to 1,008 now. Hell yeah. Uh, oh, nice. Yeah. This was the Colette's conjecture problem. If anyone can prove it, Piggy Master's professor will quit his job. Yeah, thank you for 10 bucks in color cone. It was funny because we were given this problem blind, and or like we like neither of us knew that this was the Colette's conjecture until we like played around with it and noticed like, wait, If you give it an even number, it gets cut in half. You give it an odd number, I forget what you do, like 3n plus 1 or something. Yeah, Territar, it was Papadoria. I mean, well, wait to see Goopy's question. There's a way to get a difference of squares? Do you do minus x squared plus x squared thing? No, they both want the minus sign. I mean, do you need help with it, Goofy, or just like posting it for the memes? I can look at it. Like if I can't do it, then I'll just say I give up. But oh, it's for the memes. I mean, I like look at it just for fun. But yeah, if I get stuck on it, I'll just say, you know, there's no problem I can't not solve. So I'm always happy to just walk away if needed. What the hell? For that x to the fourth plus 4 thing, I'm not seeing the trick. I want to understand what this question is though, and then decide if I even want to try to do it. No diagrams. I have no clue, Zappin. Just pretend that they're numbers and go. I like your style. Guess and check. This is part 1, and there's a 2 and 3. Wow. It does seem like a conics problem. I mean, the slope. This is disgusting. The slope of the line is that. This is terrible. I don't like, how do you show a line as tangent to a particular circle? You can show it's perpendicular. Ugh, that's terrible. Yeah, you'd have to get the point of intersection though, right? That's what's tripping me up. I mean, I guess you could also think about a different way where yeah, as Saito says, we could also get the equation of the circle. You could theoretically plug, say, the like isolate y in the equation for the line and plug it in here, and there should be only one solution for x. I guess that's the strategy you would use here. That's a whole mess of variables, though. I don't want to do that. I think that's the strategy for this problem, though. And at some point, you'll have to use this fact to simplify it. But in theory, it's some stupid-looking quadratic that you can restrict to have one solution. Series based on the college papers. Like, to get into college? Use the gradient. Really, color code? This is to, you have to do this to get into one of the top two colleges. Wow. That's stupid. One of them has another paper as well. Jeez. TMUA, not too bad. Step, I want to cry. Yeah, that question is terrible. You're a senior. What's the deal with x to the 4 plus 4? I don't see the trick. I don't think I want to delve any further into this one. So I think I see how you would do it. I just really don't want to. This is way too many letters to push around a piece of paper than I really feel like doing. It's a neat way to get a difference of two squares. No, that's okay, Goofy. I think I want to see if we can figure out the trick to factoring x to the 4 plus 4, and then I'm probably gonna have to wrap things up pretty soon. Oh, interesting, Pinbox. Have a curve defined by the zero of a function. The gradient of f along the curve is normal. And so you would try to find if that equation of the line shows up anywhere? Or like start with that and try to get to the equation of the line? Okay, so the natural thing to me to guess here is x minus 2 squared. Wait. Is it? Oh. No. No, 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 no. Sorry, the difference of two squares we were saying. Well, that gives you the wrong sign. I do remember something like that color code where the gradient being perpendicular to level curves or something. Um, can it probably be even more diabolical? That sounds terrible, Goofy. So how would I get rid of the minus 4x squared? Oh. Well, wait, do I just literally rearrange this equation? Well, no, that's not the sum of two squares. That doesn't really factor, does it? Presumably you need a middle term then? Like, is this what we do? We're getting cubics in here. We have to hope they cancel. They sure aren't. Gonna feel silly when I figure this out. I'm gonna be honest, I'm kind of not in the mood. Like, I'm kind of in the mood to just look up the answer. Just flip a sign? It's not. It's this? Don't we get a plus 4x squared? Oh, oh. Because you get that, and then you add these two things together? Is that it? Then that doesn't really factor though, does it? Hey, Lewis Carter, elimination, like for a system of equations, yeah. Oh wait, no, we have to divide it by two, but I don't think that's. I don't think that's what I don't think that's it. What I just did, I guess. Balance out the new term you added. What new term did I even add? Oh, you mean like the over two thing that I noticed or that I added in later? The idea is if you find where the two curves intersect by implicit equations. You can compute the gradient of both equations, see if they are the multiple of each other. Okay, caller. I didn't add 4x squared though. On one equation, I looked at what x squared minus 2 is, and the other equation I looked at x squared plus 2. I don't know what you mean. Well, yeah, it's off by a 4x squared. I guess, are you... Oh, this is the difference of two squares. Then you factor that. Okay, fair enough. All right, I think I'm calling it here. I'm tired, guys, and I have to get to class in 20 minutes. I'm kind of done like thinking right now, to be honest. The square root of 4x squared. Oh, you're right. I should make that a 2. I don't care enough right now to do it. All right, people who are here on YouTube, thank you for being here. I'll be back on Thursday. See ya, Papadoria.